The title of this packet is The Nature of Bonding When Atoms Come Together. In this packet, we will define a bond, discuss ionic and covalent bonding, and introduce bond order and bond length. A bond is the transfer or sharing of electrons between two atoms. Atoms bond in order to achieve a more stable electron configuration. In this packet, we will look at two types of bonds, ionic and covalent. An ionic bond involves the transfer of one or more electrons from one atom to another. After this transfer, the former becomes positively charged and the latter becomes negatively charged. These ions are held together by an electrostatic force. In this example, we have a sodium atom with 1 valence electron. Next to that is a chlorine atom with 7 valence electrons. Chlorine would like an 8th electron to obtain a more stable electron configuration. Sodium is willing to give its 1 electron to chlorine. After the transfer, sodium becomes a positively charged cation because it now has more protons than electrons. Chlorine becomes an anion because it now has more electrons than protons. These two ions are held together by an electrostatic force to form the ionic compound sodium chloride. A covalent bond involves the sharing of electrons. Electrons are shared as pairs. Multiple bonds are formed when more than 2 electrons are shared. The term bond order is used to describe the number of bonds. In a single bond, 2 electrons are shared and the bond order is 1. In a double bond, 4 electrons are shared and the bond order is 2. In this example, 2 oxygen atoms must share 4 electrons, forming a double bond. In the case of nitrogen, each atom donates 3 electrons to share with the other. Since 6 electrons are being shared, a triple bond is formed. Bond length is another characteristic used to describe covalent bonds. Bond length is defined as the difference between the 2 nuclei of a bond. It is usually measured in picometers. On the following slide, you can see how bond length and bond order are related. Carbon can form single, double, and triple bonds with other carbon atoms. As the bond order increases, bond length decreases from 154 to 133 and to 120 picometers. This means that bond order and bond length are inversely related. More bonds results in atoms that are held closer together. So far, our examples have shown covalent bonds with electrons that are shared equally. This type of covalent bond is called nonpolar. Sometimes the electrons are shared unequally. This means that at any given moment there is an increased probability of finding an electron near one nucleus rather than another. These kinds of bonds are called polar covalent, and they will be discussed in more detail in a different packet. To review, there are covalent bonds that involve shared electrons and ionic bonds that involve the transfer of electrons. Within covalent bonds, there are nonpolar bonds that involve equal sharing and polar bonds that involve unequal sharing.